As some of you might already know, I've been stripping these machines down for a little while now, with some success on some builds and not so on the others. The actual machine today, we're going to try and actually get access right down to the actual turbine shaft. As you can see, I've built my own frame. This is a bit of a unique one. It makes it easier to carry the thing around and manipulate it onto the table that I've built. Removing the top section allows easier access to all the pipes and mechanisms. Also on display, it makes it easy to see what's going on. To get the wiring loom off, I've got to actually disconnect the oil pipes first, so I'm just slackening those off, and then run around the machine and actually loosen most of the bolts with the T-bar. So I'll get rid of the wiring loom. Now I'll be able to actually move all the pipes around a bit easier, because they do tend to get in the way. One of the trouble items is the copper O-rings. They tend to compress, and when they do, they actually grit the threads a little bit, so they can take a bit of getting off. Try and avoid your screwdrivers and stuff, because otherwise you'll end up with little tiny bits of copper floating around, and if you don't flush those pipes out properly, they'll be straight down into your filter and beyond. One thing to watch out with on live engines like this ones that you've been running is when you actually take the pipes off, is to actually make sure you've got a bit of a rag so you can get rid of all the fuel, otherwise you end up with quite a lot of aviation fuel knocking around. I don't have all the caps to actually cap off the unions and oil ways and fuel lines, so a bit of a rag around the main area where we're doing it, or even using tape. I tend to use the tape quite a lot. Tape over the hole so you actually stop them getting in. This hopefully will only be a strip down for about a day or two before I start rebuilding. I've got all the parts, but it's just a matter of getting to the core itself. One of the nice things about this machine, it's quite a basic, rudimentary machine. It's pretty much all solenoids and relays, so it made it quite easy to actually build or replace the original clockwork control system. The system I'm using now is all built around an Arduino, which pretty much is a PLC with a bit of electronics and some software. So the pipes are nearly all off now. There's not many of them, so it's pretty straightforward stuff. We'll then need to hold the engine in the air once it will actually decouple it from the actual starter area. The front side of the engine, that's called the drive unit, and the rear end is the compressor and combustion chamber. although they'll make it look quite easy taking these pipes and things off, I have actually pre-loosened many of them. Also, if it's the first time when you're doing these, they will be stuck on pretty solid, so a bit of lubrication beforehand, let it soak in overnight before you tackle it, and don't just with your spanner wrench a nut off, because all you'll do is you'll snap the unions. Okay, so to take the weight of the back end, they're not particularly heavy, these units, but they're awkward. It's a bit like taking a clutch in and out of a car, I would say. You're looking at around about 25 kilos, so the use of that little jack under the bell housing for the combustion area, that will actually make the job a little bit easier. Okay, I've already removed all the nuts from around the compressor housing. It's on really tight. Try and avoid using screwdrivers and things in there. Start from one area and press against the stud to lift the actual cover up. Once you've got that going, then I just used a blunt knife blades, just slowly working around it and move it up very slowly. Make sure you keep all your nuts and bolts in separate containers. The amount of times I come back and can't find what I'm after because they've all been put together, or you've knocked something over, they've gone all over the floor. It's a pain in the backside. There's various balancing marks on this thing. There's one on the cover to make sure everything's lined up. On the main bolt of the compressor wheel, as you can see there, or the turbo, you might want to mark that before you actually remove your nut, so that you know roughly where when you tighten it back up, where you're going to be. Unfortunately, a lot of these things don't have torque settings. The way I did it was actually make sure that I got the top lock nut roughly around the same area so that the lock tab would fit, using a ratchet gun to actually tighten it up. Almost impossible to do it by holding the central shaft, because there's nothing to hold on to. I did make a little wooden pattern to hold it, but again, that didn't work so well. Always use little blocks to actually tap against, and whack any nuts, etc. straight on with a hammer. That way you just lessen the chance of you actually damaging the materials. Now, when I was taking this thing apart, occasionally you do get tiny little bits of metal, so wrapping rags around things as you go will probably help. That'll stop any little bits and pieces that you don't want wandering around. I'm just going to flush out all the bearings anyway afterwards, but again, just as you go, little precautions, they always help. Now I'm about to take out the combustion wheel here carefully. I've noted whereabouts the balancing marks are, and slowly tapping it up and out. As I pull this thing out, I had to be really careful not to damage or mark the actual roller bearings, so hence slow down at this point and pull it out. The actual main turbo shaft and compressor wheel, they're all balanced, and they're actually marked in the factory with little tiny stamp marks, and this is what I'm looking for here. So spin it round, try and find where it is. You can either do it now or do it later, whichever, but the actual compressor wheel on the shaft will also be marked, so make sure you've actually marked both where you're taking the turbo off the shaft relative to where the keyway is. One of the problems a lot of DIY engine enthusiasts find when they strip these things down is that a lot of the metal graphite coatings have either worn off or disappeared, and as you can see on one of these areas here, there's lots of very fine rings, but there's no coating because it's gone. When I first took it apart, it pretty much fell apart and came off. The other area is in the nozzle crown here. There's actually supposed to be a coating on some of them, but on the later models they've done away with it. Removing the nuts and bolts from the combustion chamber, removing them all in one go is not the best idea because you could end up with warping. It's basically 90 degrees, one opposite the other, then 90 degrees again, then take another bolt off from the opposite side and sort of rotate all the way around. So you're pretty much taking one bolt off, count 10, 15, take another bolt off. Once I've done that, I've got to split the actual two cans apart because this is what we call an annular ring combustion chamber. I used blunt utility knife blades, just tap those in here and there. Not all the way in to start with because you just want to actually try and break that seal and then work round again and around until the whole thing starts to come loose. This machine was originally designed to start other engines by pneumatics, so pretty much a great big air compressor, or should I say a small air compressor, was the job of a big air compressor. So as the actual turbine is spinning around internally, the actual main is forced out around the outside edge, as you can just see inside there. And then it's that air that's actually forced out that doesn't combust, it doesn't get mixed with any of the fuel. It goes around to the outside and it exits through a very large KP9 valve. That valve is the one that redirects the compressed air over into the bigger engines for starting. cover off, you can now see the actual combustion can that's actually inside. This allows the various different air and fuel to mix and combust. The actual flow and design of that is beyond me, so I'm just here to actually do a fixer-upper. Removing all the stripping wire here. This is the stainless steel cables to stop all the nuts and bolts that's coming loose. I did actually put all new stuff on once, but obviously I haven't taken it on because we're having a bit of a problem with this one. So we'll loosen off all of the top bolts holding on the actual fuel lines, and then move on to loosening the actual injector housings themselves. Once it's all loose, I'll then actually give them a bit of a wriggle to make things come loose, and we should be able to pop them out, keep them separate, and then drop the combustion can off the bottom. The larger hole is for where the spark plug actually pokes through. I call it a spark plug, it's actually ignition plug. On the underside of the combustion chamber then we've actually got the nozzle housing here. This is actually held on by the opposite direction, so there's no way of taking this thing apart without actually stripping right down as far as I've got if you need to take this thing out, which I do. I'm going to have it on the machine later, trying to put a new coating onto it. So once you've got it out, you can take the nuts off from the inside and then take the nozzle crown out. A lot of these bolts have been on there for quite a long time, so I'd advise putting a bit of WD-40 on it, otherwise it could be a failure. Also, we've got no spares. A lot of the bolts are stainless steel, so where possible I try and hang on to them and reuse them if possible. I've replaced all of the nuts with aerotight nuts. These are reusable lock nuts. They generally don't come loose when the engine's vibrating, so that sort of makes things a little easier. Also, it looks a little tidier as well once we've got everything apart. I'm looking for any damage here on the edges of the nozzle crown. If we've got pitting or parts missing, that will affect the actual fuel front, as well as on the combustion impeller as well. Is there any burn marks on that? Because a lot of these, if they've been run too hot for too long, the actual fins can actually melt and you'll end up with your pits or parts out, which will affect the balance of the main turbo shaft. You can see on the inside of the combustion chamber there's a sump area. This is where all the unspent fuel goes, and as far as this engine's concerned, it's just piped back out into the actual nozzle and ignited on the way out. So if it's a bit wet on the first time without using all the fuel, there'll be quite a few flames coming out the back.